Hello, this is Mr. Steinerson, and in this quick tutorial I'm going to go over the difference between when to use a constant velocity equation and when to use an uniform acceleration equation in your problems, and a few things to look out for as you're doing the problem solving like in Quest. To help illustrate this point between constant velocity, which a car would move at a steady rate, say 3 meters per second east, we can always use the equation velocity is equal to the displacement divided by the time. That in contrast to a uniform acceleration. So when we're dealing with uniform acceleration, look for clues that say things like it accelerates uniformly, or it's slowing to a stop, or speeding up from rest. When those cases are met, any of the equations that you see listed on this side of the screen will work. Notice all of them have an equation that has acceleration in it. Some of them have acceleration and time. Some of them, like equation D, has acceleration but no time. So depending on the given variables, you'll pick the equation that best fits. What does acceleration mean? Well, say we have that same car and it's traveling to the east or to the right of the screen. Well, at first it's going to start out relatively slow. So if it was doing a dot diagram, the dots would be spaced pretty close, and then they would space farther apart as it sped up. What does this look like? Well, if we space things out every second and we measure the velocity at every second, we get to see a picture of what that acceleration is. So we'll go 1 second, 2 seconds, 3 seconds, and so on. At the first second, it might be traveling at 2 meters per second. Then it increases to 4, then increases to 6 meters per second, and finally, after 4 seconds, it's going 8 meters per second. In this case, at each interval of time, each second, it was going 2 meters per second faster. So 2 meters per second faster every second, or the acceleration was 2 meters per second squared. So how can we solve equations with this information? The main question to always ask is, are we dealing with constant velocity or uniform acceleration? Look for clues in your problems. Some constant velocity clues would be that the object is traveling at a certain speed, meters per second, or the slope of your distance and time graph is constant. In those cases, always use the velocity is distance over time equation. When we're dealing with uniform acceleration, we also have some clues. The object is speeding up or slowing down. The slope of that distance and time graph changes, so you're going to see a curved line. And notice that the slope of velocity and time is always constant. Accelerations are always going to be straight lines. That means it's a uniform acceleration. And lastly, we can always use the 4 kinematic equations to solve for any uniformly accelerated problem. Whether this be a ball that's rolling down a ramp or something that's falling in free fall, all those are uniform acceleration equations. We must rearrange if necessary, but those are the 4 tools that we have.